Okay, so this is my question that I've done out here on SolidWorks here on the Hyperboloid of revolution. So to start off, what I've done is I drew up the question on SolidWorks using the layers function on that. So what we're given in the question. So the image on the right shows the CAD model for a proposed drawn that is to be located in Gort, County Galway. So design includes the surface roof, solar panels positioned to be on top. So we'll skip down to what's needed. So what I'd recommend is have a coloured pin to highlight the key information. So in the elevation, point P, which is here, is the top of the cut surface. Point F is the focal point of the ellipse, which is orientated in a portrait direction. So point F is your focal point of an ellipse, which is going to be shown here at the end. So the major axis is a distance of 45 and true lengths of all elements. So of all elements, this means your asymptote. So just note that there by writing it down. So true lengths of all elements are 120 millimeters. So that means your asymptote for your hyperboloid is 120 millimeters. So part A, draw the given plan and project an elevation of the structure below being cut. So part A is the simplest part. Okay, so we're going to start. We're given the plan view here, and we have to finish the elevation. We're given point P. We're told in the question is on the cut surface of the hyperboloid. So what we need to do first is we need to find the asymptote. For the asymptote, we draw a horizontal line across from where the throat circle here, at the bottom of the throat circle. There, set squared in. Bring that up vertical to the XY line, 2 points up vertical. So we can continue them up here like that actually. Okay, and we'll bring up this center line here for the conjugate axis. So we're told here that all true lengths are 120 millimeters. So that's in reference to your asymptote. So your asymptote runs. Remember, it's an X-like shape, and it runs right through the axis, conjugate axis here. So what we'll do here, we'll use our compass to measure. So we're going to mark it off half the distance, which is 60. So use scale in this case, so we'll go down to 30. Okay, so we just join up the bin points there. So we do the same. So the same thing is done here. So we just join this through here, and this is going to give us our height of the top of the curve for our asymptote. So what we now know is, so also that's our asymptote lines are drawn in and represented in plan. So what we can do now is bring up our throat circle here. And we bring across, so this is our conjugate axis, we bring across our conjugate axis, and that's 1 point here. We know it's on the curve. We already know point P is on the curve, we're told that in the question, and now we've found 2 further points, and these 2 points down here at the bottom of our asymptote lines and the top are 2 more points.